What's up, guys? How we doing? This is classwork for day 4. So remember, for classwork, I want you guys to always do this on your own. Okay? Everything sounds easy when Mr. A's teaching it because I'm an absolute G. I'm a homie. I know what's up. But you need to know how to do it on your own, right? Because again, it's always easy watching someone do something, but when you have to do it all on you, then it gets a little tough cookie. All right, so make sure you are doing this on your own, and then after checking your answers here. Okay, so let's go through some of these. This might be a longer video just because some of these they're a little tough. They're a little tough, but you guys are smart cookies. If you've been watching other videos, this will not be so bad. Okay, um, let's do the front. So first problem, you have a circle. I'm gonna just kind of set it up. I want to just show you that even though answers are gonna be a little strange, this will be totally fine. Okay, so OA is 10. This is 10. Okay, that's the radius, which is great. We got the radius. And then angle AOB is 40 degrees. Okay, so it wants me to find the length of arc AB. So again, whenever you see length of an arc, that's the arc length. I don't know how to spell. Look at that. What a comeback. Okay, remember, a fraction, I don't know how to spell, of the circumference, I don't know how to spell. Yeah, that's good. Okay, a fraction of the circumference will always give me the arc length. Because again, you're trying to find what is this actual distance, not the degrees. What's the actual distance of that crust, right? Is it like 6 inches? Is it 7 inches? Is it, what is it? Okay, so remember, fraction of the circumference. The fraction of what we have here, we have 40 out of the total 360, right? That's what we have. That's what we're measuring on that piece. And the circumference is 2 times pi, and my radius here is 10. Okay, so then look what we have. This is really 1/9, if you could simplify that, and this is 20 pi. Okay, and if I multiply that, we have 20 over 9 pi. Beautiful. Okay, and there is our answer for part 1. Okay, part 2, I'm going to leave alone for right now. Just remember, this is the area of the sector. So kind of go back and use what we've talked about, and you should be able to find that all on your own. The answer is a fraction. You're going to have a weird fraction answer. Okay, so try that out. You guys are absolute homie G's. So you got that. I'm going to burp again. Oh my, why am I burping? Oh my gosh, what a disgusting person. Okay. Okay, here we go. Next one. This is a little different. This is me giving you the answer. We got to go back and fix it. So PL is 8, and the area of the actual sector is this, which that is not cute in my view. Okay, so they want you to find the angle. Okay, so now it's me saying, okay, what is this angle? So, sorry, what is this angle? So I'm going to call the angle X because I don't know it. Okay, I'm going to call it X because I do not know what that is. So remember, area of sector, this is huge here. To find the area of a sector, that is a fraction of the total area. Okay, a fraction of the area will give me the area of a sector. Okay, because remember, you're trying to find the angle, but the area of a sector is just like how much actual pizza am I eating, right? Square footage of the pizza. So think about what we have. The fraction of the total, our fraction is x over 360. Because again, we don't know what degree we have out of the total. So this is where it gets fun. We have x over 360 times pi r squared, right? Area equals the area of the sector. This is the area of a sector, which again, not cute, but it'll be fun. Okay, so we're gonna have a little bit of work to do, a little bit of algebra work, but again, not bad. Okay, so look what we have. We could say this. If I have this as my problem, there's pi here and there's pi here. Okay, My pi is going bye-bye. It divides away on both sides. So if you're just freaked out about like, why do I have pi? Just get rid of it. It's not cute anymore, okay? So look what we have. This is 64. So you have 64x. That's all on top. 360 is on the bottom. Right? 360 has always been on the bottom. This is all on top. Equals 88 over 9. Okay? There's different ways to go at this problem. I set it up this way because I could do a nice and easy, cute and beautiful cross multiply. Okay? If I do the cross multiply, I get 576x equals 31,680. Woof, woof, woof. And if I divide by 576, x is 55 degrees. And there you go. That is the degree of LPM. So again, not super easy, but doable. Totally, totally doable. Okay? So there you go. There's that one. Okay, let's go to number 4. To the back. To the back. Okay, cool. All right. These questions here, okay, are a little bit tricky. Okay? So basically, about a year or two ago, me and Miss Cook went through and we're like, okay, these homies need to be good at their SAT. You guys want to see my face? You guys want look at me. Look at my face. They said they need to be good at the SAT. And SAT ain't easy. But luckily, a lot of what we do, basically everything we do, I will say that. I will go and claim everything we do is based off of what's going to be on the SAT. Okay? And even though questions may seem impossible, if you know what we've done, you're going to be great at it. Okay? So let's start on numero cuatro. Look at that zoom on this beautiful phone. Ooh, what a nice thumb. That's cool. Okay. So look what we got. We're going to find this stuff. Jasmine draws a circle with radius 9x squared. Wow. So look at Jasmine's drawing. And the radius is 9x squared. Okay. It says, what is the area of her circle? So again, don't overcomplicate things. An area of a circle is pi r squared. That's what that always is. That's what area is. Okay? But the radius is 9x squared. I don't care that you're going to get x's in your answer. I could care less. If you follow the problem and you do everything that they ask, you're going to get it right. So here we go. That's pi times 9x squared. Because again, this was r. There it is. Okay? So if I follow my process of just kind of distributing the exponent, 9 squared is 81. X squared is x to the 4th. And then pi just chills at the end. This is my area. And there it is. So again, hopefully that makes sense. Don't overcomplicate anything. It's going to be fine. You are great. Don't stress. Okay? Number 5. If the area of a circle is this nasty thing, what is the circumference? So we've done problems like this that are simple, but this is just a little worse, right? Just a little bit worse. So think about what we have. The area of a circle is this. So area equals 121x pi. Okay? We know that if I am given the area and I need to find circumference, I need the radius. Okay? I need the radius. I can't go from here to here without getting the radius. So let's use that. Area of a circle is pi r squared. Okay, we know that. This is common sense at this point. The pi's cancel out because they're ugly. And look what I have. I have r squared equals 121x. So here's what you have to do. To find r, and again, it ain't going to be cute. I can tell you that. We're going to have to square root this side and square root this side. Again, don't tweak. Because if I square root both sides, I get r here. The square root of 121 is 11. And the square root of x, because x is still underneath the square root, you're just going to keep it as square root of x because it doesn't come out, right? Square root of 121 was 11. That homie came out. That had its pair, came out. But square root of x is just square root of x. This is what it's going to stay as. This is my r. Okay? Don't worry that it looks weird. As long as you understand the algebra behind it, you're good. Okay? So then, if that's my radius, circumference was 2 times pi times r. But this is my r. So circumference is 2 times pi times 11 square root of x. Okay? You don't have to really worry about what your answer is going to look like here because think about what I got. 2 times 11 is 22. There's a square root of x right there. Remember, pi just chills out at the end. And there you got it. Okay, so again, don't worry. These are just like SAT questions, but notice, nothing I did was, burping again, was new. Okay, there you go. If the circumference of a circle triples, what? Then the area of the circle increases or decreases by a factor of what? What the Hercules is this talking about? Okay. What? Oh. I get it. Okay. Let's think about this. So we talked about this a few days ago, right? Remember from last chapter. This is from last chapter. So this is the polygon chapter. Okay, from last chapter. Remember that like if the perimeter of two shapes, let's just say two different shapes, was like a 1 to 5 ratio, right? Let's say the perimeter of two shapes was 1 to 5. As an example, okay? Then the area of those two things was when these were squared to the second power. So it's like 1 squared and 5 squared, which is 1 to 25. That's what last chapter talked about, is us taking the perimeter, and if you squared that, that would give us the ratio of area. Okay? So remember, circumference is perimeter, and perimeter is circumference for a circle. So if I have a 1 to 3 ratio for the circumference, because again, it's 3 times bigger, triples, 3 times bigger, then the area is these things squared. So that'd be a 1 to 9 ratio. Okay? So look what happens here. If I ever am given that, it's going to increase by a factor of 9, because now it's getting 9 times bigger. Okay? So really, think about from last chapter. This is just a good example. This is not the answer, but it's a good example of how to approach a problem. If you want to, you could always just make up numbers and say like, hey, if my radius is 2 and I plug it in blah, 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 what would happen here and here? So you could always do that too. All right, killing it right now. Okay. All right. The measure of a central angle is 18. Okay. If the length of the arc, the intercepted arc, so that's just saying this. If the length of that arc that it made was x pi, what is the circumference? Okay? Really not too bad. Okay? You just got to remember, if I want to find circumference, I need the radius. That's all you have to tell yourself. Okay? If I want circumference, I need radius. Okay? So with what I have, this is the only thing you got to think about. If I ever give you arc length, which is what this is, in length of the arc, okay, a fraction of the circumference is going to equal the arc length. Okay, that's something that's always true. So the fraction here is 18 out of 360. The circumference is 2 pi r. We don't know r. But remember, you need r to get the circumference. And this equals x pi. Okay, because again, fraction of the circumference is going to equal the arc length, which is what they gave us in the problem. Okay, luckily pi goes bye-bye, and we could start solving this. So look what I got. This is 1/20th times 2r equals x. Okay, 1/20th times 2 is 1/10. So 1/10 of r equals x. So that would mean that r, if I multiply both sides by 10, is 10x. Okay, there's your radius. Okay, it's not cute, it's not pretty, like me, but it works. Okay, so then what I could do is say that the circumference is 2 times pi times r, and that the circumference is 20x, throw pi at the end. Okay, and you got it. Cute, sweet, dope. Okay, love it. Hopefully you guys are doing okay on this right now. All right, let's do a fun one. Okay, this one I'm gonna draw the picture. I am not gonna solve because I am doing a lot of work. Okay, a lot of work. Okay. Oh, so I got my wisdom teeth taken out. That was really fun. I basically couldn't eat for about a week. I just had cereal today, which is pretty dope. But basically I was just a chubby faced little bunny, and it was really sad. Yeah, it was sad. So hopefully you guys know that now I lost teeth. That means my mouth is larger and I could talk more, and I could actually be louder. So that's really good. Okay. The designated fishing area of a circular pond. So again, circular pond. Okay, is marked with 2 ropes and a buoy. Boy looking. I kind of looks like a boy. A buoy at the center of the pond. So again, here's the center. That's where your buoy is. Okay. So again, it's a sector of the whole entire circle. So there's a rope. Just think, here's a rope here. Okay, the rope is 9 yards long. Okay, so the area of the of this fishing area in this pond is formed by 2 ropes, and each rope is 9 yards long, and together those 2 ropes form an angle of 170 degrees. So that's like if I put this rope here and this rope here, and this angle here was 170 degrees. Okay, hopefully that makes sense. So really just read through the problem and try to visualize that. So it says, what is the approximate area of the sector? Okay, with this information you guys can totally find it. You guys are rock stars. Okay, so this is on you to do. Okay, let's go to the next page. Oh, these are great problems. Okay, these are freaking phenomenal. Okay. A boy sits on a swing that is 2.1 meters long, okay? And he travels along the arc of a circle, all right? So let's say this is the swing, right? Here's the swing. Yay, what a cute swing. And the swing is 2.1 meters long, okay? And again, a swing goes like this, and like this, and like this. Have you ever seen like one of those like viral videos where the kid tries to go around a full swing? That would be a full circle, but usually that homie gets yeeted off to the side, cracks his head, and then there's like a little memorial after. But that's not going to happen here because, again, we're very safe swingers. We're just going to swing like this. So it travels along the arc of a circle. So he's just swinging up here, like right, like a very safe height. Then he goes back, and he swings, and he swings, and he swings, and he swings. Okay. If the swing travels through an angle of 103 degrees, then how far does he travel? So again, how far does he travel one swing? That is this distance here, okay? And if you're trying to wonder, what is this distance? Well, homie, it ain't area. This is arc length. All right? So this one's on you. So there's your picture. You guys are smart. You guys can totally get that going. Okay? Awesome. So, 2 more. Okay? This one here, the hour on a clock. Hour hand on a clock is 3 inches long. How far does the hour hand travel from 4 p.m. to 6 p.m.? Draw a clock and find the central angle. Okay, I'm sure you guys don't know what clocks even look like. I bet you some homie gonna be like, oh, draw a clock. All right, here's a clock. Yeah, this is how I look at clocks because I'm like a 21st century bozo. Okay, there's a clock. Look, where's the clock? There's our hand just happens here. That's what you bozos would do. But back in the Amish days, we had clocks like this, circular, cute, gorgeous clocks. Okay, 12 is at the top, 6 is at the bottom, tree is over here, 9 is over here. That's basically how I figure it out. Okay, and think here, there's got to be a 1 and 2. So 1, 2. This is 4, 5, 7, 8, 10, 11. Boom, look at that magic right there. Here's the center of the circle. And then you could cut in and make this. Ooh, what a good clock. What an absolute... Ooh, that's not a good clock. Holy crap. Okay, there's a clock. All right, so think about it. Really not that bad. So it says, how far does the hour hand travel from 4 p.m. to 6 p.m.? So all that's trying to find is this distance, okay, from 4 to 6. And again, it's saying how far does it travel. That, my friends, is arc length. Okay, it's saying, okay, if I measured this distance in inches, feet, whatever, boom, we have to find that, okay? So we're really looking at this slice of the clock because we're only worried about from 4 to 6. We're not worried about anything else. So let's think about that. Arc length is a fraction of the total circumference. Okay? We know the fraction because think, we have out of the 12 slices that are in a clock, we have 2 of them. 2 out of the 12 slices. That's an easy way to do the fraction. Times 2 pi, and the hour hand is 3 inches long. So 2 pi times r. Okay? You guys solve that, you'll do great. Okay? That's on you guys. Okay? And last but not least of this awfully long video, there's a flashlight. Okay, and there's a little cute flashlight. Okay, the flashlight reaches out 4 feet. So I'm going to do 4 feet here. And then covers an angle of 125 degrees. So the angle is 125 degrees. Okay, and then, yeah, right, cute. That's how flashlights look. And then it says, area 4 feet. Sorry, reaches out 4 feet, and then what the angle is 125. What is the area of the sector? Area of sector. So this is on you guys, but just so you have the picture. Okay, hopefully that made sense. Part 2 is actually coming up in another video, so that one's a little tricky too. I'm going to do that in a second, and hopefully you guys feel Gucci with that. Okay, bye.